Have you ever truly looked up at the night sky, far from city lights? That faint milky band is the Milky Way, our home galaxy, a river of light made of countless stars. For as long as we've been human, we've wondered, how many stars are there? It sounds simple, but the universe rarely is. Counting the stars in our galaxy is one of astronomy's greatest challenges, a cosmic puzzle that pushes our technology and imagination. The answer isn't just trivia, it's a key to understanding our galaxy's history, structure, and potential for life. But there's no precise number, just scientific estimates based on clever methods and powerful observations. The number is so vast, our brains can barely process it. Imagine trying to count the trees in a forest, billions of light years wide, while standing inside it. On a perfect night, you might see a few thousand stars, just our immediate neighborhood, but the vast majority are invisible, too far, too faint, or hidden behind cosmic dust. So how do we count what we can't see? That's where science gets creative. This journey to count the stars is a testament to human curiosity and our drive to understand our place in the cosmos. We build bigger telescopes, develop sophisticated models, and send probes into space for a clearer view. Each discovery refines our estimate, bringing us closer to grasping the true scale of our galactic home. So, let's embark on this cosmic census. We'll explore the methods, the challenges, and the mind-blowing numbers scientists have uncovered. Prepare to have your perspective shifted. The universe is waiting. Let's begin. How do you count the uncountable? Let's find out. Welcome to the Milky Way. Before counting stars, we need to grasp the Milky Way's sheer size. It's a barred spiral galaxy, a giant spinning pinwheel of stars, gas, and dust. Our solar system sits in one of its spiral arms, about 2/3 from the center, a quiet suburb in a vast city. The Milky Way is about 100,000 light-years across. A light-year is nearly 10 trillion kilometers. Even the fastest spacecraft would take over 1 billion years to cross it. Our entire history is a blink compared to the time it takes to orbit the galaxy. The main disk is about 1,000 light-years thick, but the central bulge is much denser. Our solar system orbits the galactic center every 230 million years, a galactic year. The last time we were here, dinosaurs were just appearing. We live inside this colossal spinning structure, trying to count its stars from within. It's like counting everyone in a city while stuck inside your house, peering through foggy windows. That fog is interstellar dust, obscuring much of our view. We don't have a bird's-eye view. We're inside the machine, guessing at its parts. This is the fundamental challenge of our cosmic census, but with creativity and technology, we can still make remarkable estimates. The scale is beyond human experience, but not beyond human curiosity. Let's see how we bridge this gap. The journey continues. Numbers like 100,000 light-years are so huge, they lose meaning. So, let's use an analogy. Imagine the sun as a grain of sand. Earth would be a dust mote orbiting it from 2 inches away. The nearest star, Proxima Centauri, would be another grain of sand, 4 miles away. That's how empty our stellar neighborhood is. Now, scale up. To represent all the stars in the Milky Way, you'd need enough sand to fill a 3-story building. Every grain is a star, many with their own planets. Still hard to grasp? Scientists estimate there are about 7.5 quintillion grains of sand on Earth. Yet, the Milky Way has between 100 and 400 billion stars, meaning for every grain of sand, there are at least 10 stars in our galaxy. These analogies help us bridge the gap between abstract numbers and reality. When we say 200 billion stars, it's almost meaningless, until you picture a building full of sand, or realize there are more stars in our galaxy than grains of sand on all Earth's beaches. That's the true immensity of our galactic home. Each star is a potential world. The numbers are staggering, but they're real. Our galaxy is vast, beyond imagination. And we're just getting started. Let's see how we peer through the darkness. One of the biggest obstacles to counting stars is dust. The space between stars is filled with fine, smoke-like particles, interstellar dust. Over vast distances, this dust blocks visible light, creating dark clouds that hide stars. The densest dust lies in the plane of the galaxy, right where most stars are. Looking toward the galactic center, our view is almost completely blocked. Traditional telescopes can't see through this cosmic fog. So, astronomers switch to infrared and radio waves, which pass through dust. Infrared telescopes like Spitzer and James Webb reveal hidden stars. By observing in different wavelengths, we piece together a more complete picture. Without this approach, our star counts would be wildly off. Infrared light is our key to seeing the unseen. Our ability to map the Milky Way has leapt forward thanks to the Gaia mission. Gaia isn't counting every star, but it's measuring the positions and motions of over 1.8 billion stars. It uses parallax, measuring tiny shifts in a star's position as Earth orbits the Sun, to calculate distances. Gaia's data gives us a dynamic, six-dimensional map position and velocity for each star. We can see the intricate dance of stars and the structure of our galaxy. By understanding the regions Gaia can see, scientists extrapolate to hidden areas. This lets us model the galaxy's structure and estimate its total star count. Gaia's map is the foundation for our modern estimates. It's a revolution in our understanding of the Milky Way. Counting stars one by one is impossible, even for Gaia. So, astronomers weigh the galaxy, using the motion of stars to estimate total mass. But there's a twist. Stars move faster than expected, hinting at invisible mass, dark matter. About 85% of the Milky Way's mass is dark matter. Astronomers subtract the mass of dark matter and gas, leaving the total mass of stars. But stars come in all sizes, from massive blue giants to tiny red dwarfs. To get a star count, we need the average mass of a star. It's not a simple average. Most stars are small, but a few are huge. This distribution is called the initial mass function. By understanding it, we can turn the galaxy's total stellar mass into a star count. It's like figuring out the population of a city by knowing the average weight of its residents. This method, combined with Gaia's data, gives us our best estimates. The process is complex, but the result is astonishing. Let's meet the stars that make up the majority. The stars we see are the big, bright ones, blue giants and red supergiants, but these are rare. Most stars in the Milky Way are small, cool red dwarfs. Red dwarfs are lightweights, burning fuel slowly and living trillions of years. They're incredibly faint. None are visible to the naked eye, even though our closest neighbor, Proxima Centauri, is a red dwarf. This creates a huge bias. We see only the brightest stars, missing the vast majority. Red dwarfs make up about 75% of all stars in the Milky Way. If the galaxy's mass is mostly in red dwarfs, the total star count is much higher. Deep surveys confirm our galaxy is overwhelmingly a galaxy of dwarfs. Understanding their proportion is critical to getting the count right. The unseen population shapes our entire estimate. The Milky Way is a city of hidden stars. Let's put it all together. We measure the galaxy's rotation to find its total mass, subtract dark matter and gas, and get the stellar mass, about 40 to 60 billion times the mass of our sun. Divide by the average mass of a star, much less than the sun thanks to red dwarfs. And you get the final count. The Milky Way is thought to contain between 100 and 400 billion stars. Some estimates go even higher, but let's stick with 200 billion. If you counted one star per second, it would take over 6,000 years to finish. And that's just our galaxy. The Milky Way is one of an estimated 2 trillion galaxies in the observable universe. The total number of stars is functionally infinite from a human perspective. It's a number that should fill you with awe. Our universe is fantastically, unimaginably full, and we're a part of it. What does it mean to live in a galaxy with hundreds of billions of suns? With so many stars, the number of planets must also be astronomical. Most stars have planets, even if only 1 in 5 has an Earth-sized world in the habitable zone. That's 40 billion potentially habitable planets in our galaxy alone. This changes the question of life elsewhere from if to where. The distances are vast, and complex life may be rare, but the numbers suggest we're likely not alone. Our sun is just one of hundreds of billions. Our Earth is a tiny world orbiting an ordinary star in a vast galactic city. All our history has played out on a microscopic stage in a boundless cosmic arena. This isn't depressing, it's liberating. We're part of a grand cosmic story. The quest to count the stars is an expression of our need to understand our context. Next time you see that milky band of light, remember, it's the combined glow of billions of suns. You're a part of that cosmos, a way for the universe to know itself.